See, in this particular problem we have two metal spheres with us. So two metal spheres are such, you can see that two metal sphere, one of radius r and other of radius 2r. So I'm just taking one sphere, say this is one sphere having radius r and another sphere is having radius 2r. Okay, so these are the two spheres we have in this particular case. So what I can say is, let us say this is the adjusted. Okay, these are the two spheres. Now this particular sphere is having radius r and this particular sphere is having radius 2r. Okay, so I'm just writing the things. So this is having radius r and this is having radius 2r. Both have same surface charge density sigma. So charge density for this sphere and charge density for this sphere both are sigma. And now I'm just making them in contact with each other. Okay, let us say charge on this particular sphere is q1 and charge on this particular sphere is q2. So now what I want to just do is that let us first of all find the charges on the sphere. So charge on the first sphere q1, that is sigma into area of the sphere would be 4 pi r square, and charge on the second sphere is going to be q2, and that is basically sigma into 4 pi then 2r square. Okay, so it is going to be, I can say 16 sigma pi r square. So this is basically, I can say 4 times sigma into 4 pi r square, and you can see this is 4q1. So this q2 is nothing but 4q1. Okay, this q2 is nothing but 4q1. Now when these two spheres are made contact, because they are connected with conducting wire, so when these spheres are connected by, I can say, wire. Okay, when these spheres are connected by wire, their potentials will become same, and their charges after this connection, you know that charge on the sphere after contact is written as, कैसे लिखते हैं अपने, पहले sphere का radius, नीचे r plus 2r, and then total charge, and q2 dash कैसे लिखते हैं, तो के दूसरे sphere का radius upon r plus 2r into total charge. So it is going to be q by 3. Okay, and here it is going to be 2 by 3q. It is 1 by 3q, it is 2 by 3q. But capital Q, you know that this q1 and here it is 4q1, so total charge is 5q1. So it is 5 by 3q1, and here it is 5q1 here, so 5 to the 10 by 3q1. Okay, so this is what we have after connection. After connection we will be having this charges on the sphere. Now what? So let us proceed further, because we want to calculate the surface charge density of each sphere after this connection, right? So how to find the surface charge density, that is q dash upon area. So let us write down for first sphere. For first sphere, charge q1 dash is equal to 5 by 3q1, and therefore surface charge density sigma 1 is basically q1 dash upon 4 pi r square. So q1 dash is 5 by 3q1 and divided by 4 pi r square. Okay, now you can see that q1 upon 4 pi r square was the initial surface charge density, so it is 5 by 3 sigma. For second sphere, q2 dash is, you know that 10 by 3q1, and surface charge density sigma 2 is going to be q2 dash upon 4 pi. Radius of the second sphere is 2r, so it is going to be, I can say q2 dash is basically 10 by 3 q1 divided by 1 upon 4 pi 2r whole square. So it is basically 10 by 3 sigma, sorry 10 by 12 sigma, sorry, see, let me correct it, because see, we have something like this, 10 by 3 q1 1 upon 16 1 upon pi r square. So on the basis of this I can just write, so 10 by 12, okay, then 1 q1 upon 4 pi r square, and q1 upon 4 pi r square is sigma, so 10 by 12 is 5 by 6, and this is sigma. So from this calculations we can say that after connection sigma 1 is 5 by 3 sigma and sigma 2 is going to be 5 by 6 sigma. So that's all, guys.